Dear students, let's continue with our from the yesterday's class. So today we should have one more example to find out the transfer function using signal flow graph. So this is the example which we have taken in order to find the transfer function. First and the foremost thing we have to write here is the transfer function. So the transfer function given by Mason, that is Mason's gain formula, is T of S, which is indicated by T of S, which is the ratio of C of S by R of S, is given by, for all values of K, Pk delta K upon delta. So first thing what we have to do here is to find the forward paths. So in this we have to find out how many number of forward paths are there. As a repetition or by the definition, we know very well what a forward path is. A forward path is a path from input node to output node without entering into the same node at once. So it should not, that path should not enter into any of the nodes more than once. When it is connected from input to output, then we can treat that to be as a forward path. All that I have to do here is to find out how many forward paths are there in this particular problem. So now let's find out how many forward paths are there. So carefully you just see here, this is the one, it starts here. So the gain of this being what? 1, then G1, G2, G3, G1. So I can designate this by P1. So P1 to be first forward path with forward path gain being G1, G2, G3. So G3, this is multiplied 1, anything multiplied by 1 will be the same. So first forward path being G1, G2, G3. So one forward path. Let's find out like whether still more forward paths are available in this problem or not. So now let's take one more. You can see here, this is another one like G4, G5, G6, and then it's connecting to the output. So second forward path being G4, G5, G6. Then let's see whether still more any paths are existing or not. So let's see here one more, G1, G8, G6, and it's reaching the output node. So I can have one more, that is P3, G1, G8, G6. Now G4, G7, G3, and it's reaching the output node. So one more forward path is existing, that is G4, G7, G3. Are there any other? Let's find out. So you can see here, carefully observe here. So G1, G8, H2, G7, G3, and it's reaching. So if you carefully see this particular path, nowhere the path is entering into a particular node more than once. So hence I can treat this to be as one more forward path, that is P5. So P5 being G1, G8 minus H2, G7, G3. Then G4 on the same lines, G4, G7 minus H1, G8, G6, and then output node. So I have one more forward path which is having the gain of G4, G7 minus H1, G8, G6. So totally in this particular problem we have totally 6 forward paths, and the respective forward path is indicated as shown here. Now forward paths over. Next is to find out how many loops are there here. So loops are nothing but loop. How we define the loop? A loop is the one which starts at the same node and then ends at the same node. So consider this loop. It's just going here and it's entering into the same node. I can treat this to be one loop. So obviously the loops are denoted by L1. L1 is equal to minus G2 H1. Minus G2 because minus H1 I have. So I have just taken minus G2 H1. The loop gain being minus G2 H1. Then one more on similar lines. So this is G5 and this is minus H2. So L2 will be minus G5 H2. Then any other loops we need to find out. Carefully you have to observe here whether we have so you consider here we have this line which is forming. Okay, we have this that one more loop you can see here, that is minus H1 G8 minus H2 G7. This is one more loop you can just see here, which is in the form of 8. If it is in the form of 8, you can see here, if it is in the form of 8, if I just open, then obviously you can treat this to be a loop. You can treat this to be 8. So suppose if this is an 8, right? If this is an 8, if I just open this, that becomes a loop. In the similar fashion here also, it is G7 minus H1 G8 minus H2. So one more loop I have with loop gain being L3 minus H1 G8 minus H2 G7. So minus minus becomes plus. I can write this to be H1 H2 G7 G8. Now we need to find out non-touching loops. We know very well non-touching loops are the loops which does not share a common node. So totally we have how many loops? 3 loops. This loop being L1, this loop being L2, and the one, this outer one being the L3. I will be just writing that as L3 here. So I need to find out the combination of non-touching loops here. So first, minimum required is 2 loops taken at a time which are not touching to each other. So L1 and L2 are non-touching. So I can write this combination, that is loop 1, loop 2. The combination of these two to be non-touching to each other. Next, I can take a combination of L1 and L3. If I take this, obviously we can see that this loop and this loop do share the common nodes here as well as here. So I can't consider this to be a non-touching loop. Similarly, on the same lines, L3 and L2, these two are sharing common node. Hence, the rule fails here. That is, we are not supposed to consider this to be non-touching loops. So hence I have only one combination of non-touching loops, taken 2 loops at a time, that is L1 and L2 with the respective loop gains mentioned here. Now let's take the next combination, that is non-touching loops, taken 3 loops at a time. So it is highly it cannot be taken because you can see here L1, L2, L3, they share common nodes here. So there is no combination of 3 loops, non-touching loops taken 3 at a time. Now is to determine what is delta. So by definition, delta is given by 1 minus summation of loops. So the loops will be L1 plus L2 plus L3. If it is minus, then will be plus. Now summation of non-touching loops. So L1, L2. Then again minus summation of non-touching loops taken 3 at a time. There is no such combination. So the next thing, whatever we will be getting will be 0. Here and afterwards, whatever we consider here will be 0. Now we need to find out what is delta k. delta k, so that we need to substitute here. So delta k is same as delta, but we need to consider only those loops which do not touch the kth forward path. So now I am considering first, that is delta k, meaning here delta 1, because p1 means correspondingly I will be finding out what is delta 1 here. Delta 1 will be same as delta, that is 1 minus, but here I need to consider the loops which are not touching to the kth forward path. This path being G1, G2, G3. So if you consider this path here, L1 is touching and L3 is touching, but L2 is not touching. So hence I consider only L2 here. So plus non-touching loops taken two at a time. So any of the combination you take, since I am considering the first forward path here, that is G1, G2, G3, nowhere I can consider L1 because it is touching that. So the second one, that is L2, I can consider, but for non-touching loops minimum 2 loops should be there. So L3, if I consider L3 is again touching, so there is no combination of non-touching loops here. So delta 1 will be just equal to 1 minus L2. On the similar lines, I need to find out what is delta 2. Delta 2 will be 1 minus of, so delta 2 is G4, G5, G6. To this particular path, the loop which is not touching to touching that particular path is L1. So hence I consider this non-touching loops combination which is not touching the kth forward path will be 0, and hence it is 0. Then delta 3 I am going to take, that is 1 minus of, delta 3 is G1, G8, G4. G1, G8, G1, G8, G6, sorry, it's not G4, it's G6, G1, G8, G6. This is the third path which we have considered. For this path, if you see here, L1 is touching at this point. Obviously, L2 is touching at this point and L3 are touching here at this point as well as at this point. So hence, we don't have a combination of loops or non-touching loop combination, it will be just equal to 1. On the similar lines, delta 4 you take. So delta 4 is G4, G7, G3. Again for this, all the 3 loops are touching. So I'll be having 0 loops here. So delta 4 will be just equal to 1. Then delta 5. Delta 5 is this one, that is, which is in the form of an 8, that is H1, G8, H2, G7 in this manner. So if I consider this, all the 3 loops are touching, and hence I'll be getting delta 5 to be also equal to 1. Similarly, delta 6 is calculated in the similar fashion. So delta 6 will also be equal to 1 because all the 3 loops are touching to that particular forward path. Hence, I can't consider the loops which are touching to that. So it will be just equal to 1. So this is how we have to find out all the requirements, so that I need to substitute in this Mason's gain formula in order to find the transfer function using signal flow graph technique. So we have found out how many paths are there, how many delta k's, then loops, non-touching loop combination, and finally delta. Now is to just substitute here in the final expression. So it is P1 delta 1 plus its summation, algebraic summation, P2 delta 2 plus P3 delta 3 plus P4 delta 4 plus P5 delta 5 plus P6 delta 6 upon delta. So now is to substitute here the values of P1 delta 1 and delta here. So P1 is G1, G2, G3, delta 1 being 1 minus L2. So for L2 gain we will be taking. So L2 is minus G5 H2. Then P2 is G4 G5 G6 into delta 2. Delta 2 is 1 minus of L1. L1 being minus G2 H1. Then P3 being plus G1 G8 G6, delta 3 being 1. So this will be just equal to 1. All these will be just equal to 1. Anything multiplied 1 remains the same. So I won't be multiplying, or if you want you can just take it as 1 plus P4. P4 is G4 G7 G3 into 1 plus P5. P5 is G1 G8 minus H2 G7 G3 into 1 plus P6 into delta 6 G4 G7 minus H1 G8 G6 upon delta. So delta being here 1 minus of summation of all the loops here, that is minus G2 H1 plus minus G5 H2 plus H1 H2 G7 G8 plus L1 L2 combination. L1 L2 combination is G2 H1 G5 H2. Now one more step, which is just a simplification of this. I'll just write G1 G2 G3. Anything into 1 is G1 G2 G3, minus into minus it becomes plus here. It becomes plus, then multiply here, that is G1 G2 G3 G5 H2 plus G4 G5 G6. Again minus into minus here becomes plus G4 G5 G6 G2 into H1. The rest all remains same, that is G1 G8 G6 plus G4 G7 G3. Here I'll write minus because we have minus H2 here. Minus G1 G8 G7 G3 H2 minus, because minus into plus is minus G4 G7 G8 G6 and H1 upon delta. Delta is 1 plus G2 H1 minus, so here I will be getting plus into minus, minus into minus becomes plus here, that is G5 H2, as it is plus again plus into minus it becomes minus here, minus H1 H2 G7 G8, then plus G2 G5 H1 H2. This is the final transfer function, which is T of S, found using Mason-Gain formula for this particular problem.